Virtually all instructors and content creators in STEM fields want content to be usable to everyone. This presentation will explain some of the key things to do and not to do to make science, technology, engineering, and math more usable for people with disabilities. What do I mean by accessible? One definition highlights that individuals with disabilities need to be able to independently acquire the same information, engage in the same interactions, and enjoy the same services within the same time frame as those without disabilities with substantially equivalent ease of use. To further illustrate the idea of usable content for everyone, this comic was selected to highlight that certain tasks favor certain groups more so than others. A bird, monkey, penguin, elephant, fish, seal, and dog are given the same task to climb the tree. Clearly, there will be some barriers for the other animals to accomplish the same feat as, say, the monkey. Where to start? For those new to accessibility, it can be really confusing where to start. Hopefully, the remainder of this presentation will describe some of the people who need accessible STEM content as well as practical takeaways. First, let's talk about ways people use technology. This is a picture of someone trying to replicate the experience of being a screen reader user. This person has a blindfold on, and they are using a screen reader to navigate their computer. The screen reader will speak everything aloud, from pictures, links, headings, text, buttons, lists, and even math, if math has been created accessibly. Screen reader users are typically blind. Text-to-speech refers to software or an app or other tool that is designed to speak text out loud. Often text-to-speech tools have functions like highlighting, save as MP3, changing line or word spacing, and helps with dictionary and thesaurus. Text-to-speech is often a necessity for people with learning or visual disabilities. Some of you have heard of dyslexia, and some of you may not have heard of dyscalculia. Dyscalculia is a learning disability where mathematical concepts and numbers are often mixed up or hard to grasp. Having the math spoken aloud helps the user to check what they are seeing visually. The combination of seeing and hearing the math creates a more ideal environment for learning. Now let's talk about some ways math is created. LaTeX is the de facto standard for publishing math in printed form. Many STEM content creators are familiar with LaTeX, and it can be generated manually. On the screen is an example of LaTeX. It's actually a table in LaTeX form. MathML stands for Math Markup Language. It was designed for publishing on the web and applications and is to be generated automatically, meaning you use a tool to create MathML. It's typically longer than LaTeX, and it's very rare that a human would write MathML by hand. MathType is a standalone tool and a plugin for Microsoft Word that will produce mathematical content in MathML. Screen readers and some text-to-speech engines will be able to read MathML content properly. MathType ideally would be used by all STEM content creators as it creates math that can be read aloud with adaptive technology. It can also oscillate between LaTeX and MathML. One easy way to help make your STEM content more accessible is to keep the original source files. It is possible that these source files may save a lot of time and work in reconstructing the document should it need to be converted for a specific need. Always keep the original files you use to create STEM content. Even outside of STEM accessibility, content creators need to add alternate text, also known as alt text, to their images. This can be done in Microsoft Office by going into Format Picture, then finding the alt text option. Describe the image in a way that someone who is blind understands the main purpose of that image. Be prepared to explain complex images. You will need to break down the different parts to communicate the importance of the information contained in the graphic. Start with a general statement like flowchart of XYZ. Then pretend to describe the image as if you were doing so for someone over the phone. To ensure that adaptive technology can be used with tables, the header row will need to be repeated at the top of each page. There is a function in the table properties to do this action in Microsoft Office. Otherwise, the user may get lost if the table spans multiple pages. As of March 2018, MathML is really not supported in PDFs, generally speaking. Thus, it is best to avoid saving documents in a PDF format. If they are, they will need to be completely reconstructed into a MathML Word document or HTML with MathML. At the University of Washington, it takes an experienced team 10 times the amount of time to convert STEM textbooks as it does non-STEM textbooks. This is because we are often recreating the mathematical expressions from scratch, which is more complicated than recreating text. We recognize that a lot of work goes into creating and sharing content in an instructional setting. It would be best practice to have your materials ready to go at least 2 weeks in advance. This way, materials can be retrofitted if needed and delivered in a timely manner. Please note, making Braille, tactile graphics, 3D images, and captioned video content will often take more than 2 weeks. There are several technologies designed to help students learning STEM content. It is important to inquire and test the accessibility of these tools before purchasing and using them. Otherwise, tools will be purchased that cannot be used with screen readers, text-to-speech software, and speech-to-text software. Seek the assistance of accessibility professionals. It is not realistic to expect that instructors and content creators will know everything about accessibility. Look for the accessibility professionals within your organization. They can be disability service people, IT people, instructional designers, or other faculty. Don't try to do accessibility alone. In summary, understand that STEM content creators typically use LaTeX, which was designed for the printed world. But MathML is designed for the electronic world, and MathML is more usable with adaptive technologies than LaTeX. Avoid using images and PDFs of STEM content. Always add alt text, and ask for help with more complex accessibility questions.